Hi there guys, welcome back to the channel. Today we're going to be looking at starting another repair project. So someone has brought me these parts. These parts are from a petrol powered Wacker plate. We'll have the main support bearing block, we'll have two seal flanges and the main drive shaft. As you can see, the main shaft has split due to excessive use throughout the years. So this was partially disassembled when it was brought to me. I have since removed the other side seal plate to be able to achieve some proper measurements off that one, as this side here has split away on all of the fixture points. The castings have just split, so I'm not sure if that was part of the issue initially or whether the shaft had just sheared and then this has been a result of trying to disassemble the machine. I'm not sure. So my job here is to make up a replacement shaft to suit this gearbox with 8mm keyways either side, two bearing races, well, shoulders for the bearings to slide onto, and then a tapered fit for the drive pulley itself, and an M12 1.75 pitch thread on the end, as it's been mushroomed out when it's been hit to drive the shaft out of the gearbox. So shouldn't be too hard, this project. Nice little one. I've ordered in the parts now. I've got a stock bar here of some EN 24A grade steel. That is, I believe, about 200mm long by 50mm wide. So I'll be machining that down to an overall diameter of 38mm first, and then from that point I'll be working in all the features of the part onto this shaft. And once I've completed this shaft, then I'll move on to the lathe and possibly the milling machine for making up this seal flange. Cheers guys, looking forward to this project, should be a good one. Right then guys, we're over at the master. Going to be putting this 50mm round stock into the 3-jaw chuck and turning down to the overall diameter for the first inner shoulder of 38mm. So get this turned down to size and then swap the part round, turn the other side, and then we can start working on the shaft. So with the part chucked up in the machine, I'm now going to turn down the outer diameter to 38mm using the DRO on the machine to take the measurements. So I've got it zeroed out at the center of the part there, so I can just work my way down to half of 38, which is 19mm. Alright then guys, so after the past couple of videos there, I've been machining down the outer diameter of this replacement Wacker shaft. As you can see, I've blued up the shaft and marked out the lengths of each segment of the part so I can work to a fixed line, just to give me a visual reference for the measurements. And then I'm going to start turning some of the features onto this part. Running the lathe running this part between centers now with a drive dog. Running the lathe at 500 RPM and I believe 0.020 inches feed rate. Alright there guys, so moving on to the next stage of this project, we are going to be turning down the bearing seal flange for this Wacker plate restoration that I'm working on. So we have some 200mm by 20mm aluminium round stock. I've just chucked it up in the jaws there, in the forejaw. Got it running nice and true. So what I'm going to do now is bore a 20mm hole through the centre of the part, and then I'll be making a mandrel to turn the outer diameter of this flange. So that hole should be to 20mm, give or take, and I need to take out another millimetre to match up the mandrel that I've got. Swapped over to an 8mm boring bar to take the centre diameter from 20mm, give or take, up to 21.5mm. Alright then guys, so we're now up to a stage where we've got the stock billet of aluminium faced off on one side and bored through to fit very snugly onto a mandrel. I've now got it clamped up into the lathe with the drive dog onto the mandrel, and I've just been trimming it in with the dial indicator there, and I'm pretty happy with how I've got it. Only so now with this set up on the mandrel, I'm going to turn down the outer diameter, as this stock is considerably larger than what I need, but it was the quickest available piece that I could get ordered up in time. So I'm going to turn down the majority of the outer diameter, and then the part can come off the mandrel once I've reached the final OD, and then it can go back into the forejaw for the final machining. Just touch off the cutter onto the part there, zero out the DRO, and measure up for a 1mm depth of cut. Dial in for 2mm overall depth of cut. See how the machine can handle it in aluminium on the drive mandrel. Going for a 5mm overall depth of cut, 2mm actual cutting depth. Getting closer to the overall diameter, so I'm just checking every couple of passes, make sure I'm where I think I am. Hi there guys, so we're over on the Alfred Herbert vertical milling machine. Today I'm going to be working on milling the two keyways, 8mm keyways, into this Wacker plate drive shaft or vibration shaft. So these keyways are 8mm wide by 20mm long. I've got the shaft set up in my rotary dividing head, and I've got a supporting tailstock on the far side there just to help with rigidity of the setup. And I'm just about to start my first cuts on this side, and then I'll be swapping the part around and taking cuts on the next side as well. Zero out the end mill on the part, and then I'm going to drive it down 4mm. One mil depth of cut. Two mil overall depth of cut. Engage the power feed to 18mm width of slot, including the end mill. 12mm, sorry, not 18mm.